good morning, good evening, good afternoon, depending on the geographical location in which you are residing. This series of lectures is known as Padma Shri Dr. SR Valluri Memorial Lecture Series. This series is held on all Saturdays. Timings 6 p.m. to 8 p.m. as per Indian Standard Time. This is a virtual program through Zoom. All are welcome irrespective of their geographical locations. Thanks to Corona for having made this possible. The topic for discussion on this 11th session in Zoom meeting platform on today, the Saturday, 19th February 2022 from 6 p.m. to 8 p.m. as per Indian Standard Time is user-friendly interactive C programming. This is part 2. Part 1 was held on last Sunday, which was the 10th session on Zoom. Learn free from any place, learn free at any time, learn free at any pace. This is an Atmanirbhara Bharata initiative. This program is called as lecture series. However, wherever possible, discussion method will be utilized to the extent possible for exchange of ideas among the participants, including but not limited to the speaker, for the purpose of encouraging everybody in terms of thinking, in terms of learning, in terms of problem solving, and in terms of understanding the topic of interest. The resulting multiple points of view is expected to help to build better knowledge, understanding, and interpretation of the topics discussed. Disclaimer: the information contained in this program is collected from several sources and studied, simplified, and standardized, and efforts have been made to see that it is error-free. But every keystroke is itself an important source of error, and therefore the participants as well as viewers are requested to use the information contained in this program at their own risk, knowing well their own personal limitations, if any. About this lecture series or discussion series, participants as well as the viewers of this program are welcome to use this program using one of the following methods. Method 1 is participate in the virtual session through Zoom. To receive the link to join virtual session, please send your name via email ID to x9t9@yahoo.com. Method 1 continued. Use the link to join virtual session wherever free Wi-Fi is available so that you will be able to save money which is otherwise spent on data providers. Method 2. If unable to join the virtual session for any reason whatsoever, link to view and or download the video recording of the virtual session will be made available. Method 2 continued. Use the link to view and or download the video recording of the virtual session wherever free Wi-Fi is available to save money, and view the recorded video as many times as required to become an expert in the subject without the need for constant internet connectivity. Method 3. View the downloaded video on a USB pen drive by just plugging it into input port on a TV to view the lessons on a bigger screen without the need for constant internet connectivity. Please spread the message about this series of free lectures, free discussions through all your contacts so that somebody in some corner of the world will be able to get some benefit by attending the virtual program or viewing the recorded video of the virtual sessions. Those who wish to part with their knowledge and experience for the benefit of younger generations are welcome to send their name, the name of the topic on which they wish to talk, and the date and time convenient to them to do so to x9t9@yahoo.com. Everybody is welcome to donate in the form of giving honest opinions, meaningful suggestions, and constructive criticisms with the purpose of improving the quality and clarity of the presentations in the future sessions, which will be received with calm, clear, and open mind. Until now, a brief revision on what was covered in the previous session before introducing new additional ideas on writing user-friendly, interactive programming in C language using audible alerts wherever and whenever needed as desired by the programmer will be discussed. C is one of the programming languages which is nearer to both the users as well as the machine. C as a programming language has its own character set. The character set in C is broadly divided into three main types or categories. They are letters, digits, and special characters. To make learning a language simple, the letters used in the C programming language are the English alphabets. These are further divided into two main groups. One is the uppercase letters and the other is lowercase letters. The uppercase letters are A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So A to I, there are 9 letters, J to R, there are 9 letters, and S to Z, there are 8 letters. Totally, there are 26 uppercase letters. The handwriting style depends on individual. A sample handwritten style given as fonts in the computer are shown here. What is important is the users are required to write the letters, the digits, the special characters, so that each one of the letters, digits, and characters are unique. That is, we should not be able to confuse with a small letter C and a capital letter C with a opening bracket, for example. Similarly, the letter I, the digit 1 should not be confused. So, they must be clearly written such a way there is no confusion between I and letter 1. And in fact, small letter L also resembles number 1 in the keyboard. Similarly, letter Z and digit 2 should be written such a way that Z and 2 are differentiable from one to the other. Similarly, the letters S and the digit 5 should be carefully written so that S and the letter 5, digit 5 are easily distinguishable. Similarly, the letter O and the digit 0 should be differentiated properly so that no confusion exists between the letter O and the digit 0. The lowercase letters are again A to I, there are 9 letters, J to R, there are 9 letters, and S to Z, there are 8 letters. Totaling, there are 26 lowercase letters. That means there are 26 uppercase letters from A to Z and 26 lowercase letters from A to Z. Totally, there are 52 letters of lower case and uppercase letters which are used in writing the programs in C language. The handwriting of the lowercase letters also varies from individual to individual. As explained earlier, the users and programmers must be able to write such a way that they will differentiate between a lowercase letter C and an uppercase letter C with that of a opening bracket commonly known as parenthesis. Similarly, the letter I, the number 1 and the small letter L which is produced by pressing the keys on the keyboard, they should be clearly distinguished from one another while writing using handwriting. Similarly, the letter O and the digit 0 should be carefully identified so that programs written by hand, when it is read by the data entry operator or anybody else, should be able to distinguish between what is letter O and what is the digit 0. Similarly, the letter S, whether it is capital letter S, small letter s, or the digit 5, they must be clearly identified from one another so that no errors are committed by the persons who process this handwritten information, probably to convert it into machine readable form of data. It is invariably necessary that difference between small letter u, capital letter U, small letter v, capital letter V must be also clearly distinguished when written by hand on the paper. The number 2 and the letter Z, whether small or big, must also be identified clearly so that there will not be mistake. It is possible sometimes the letter 1 written may have to be differentiated from the digit 7, and therefore proper care must be taken while writing the number 1 and number 7 so that there is no confusion for the people involved in further processing. The decimal digits are 10. Deci in language means 10, and these are the symbols that are used, decimal digits. They are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The smallest number is 0. The largest number is 9. Therefore, there are 10 different digits in the decimal numbering system, which are used in addition to 52 letters which are included in the character set of the C programming language. The handwriting of the letters 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 are also shown on the screen. This style of writing depends from person to person. Here you can see number 7 is differentiated from the digit 1 by drawing a horizontal line on the vertical portion of the line of the digit number 7 as shown in the screen. One of the most important special character is what is called as blank or space. This is an invisible character produced when we press the space bar. So, to indicate in handwriting, generally the letter small b is written or lowercase letter small b is written, and a line is drawn either horizontally or inclined, which passes through the lowercase letter b as shown on the screen. So this is to represent the invisible space or blank when we press the space bar on the computer keyboard. In handwriting also there will be small difference in writing. So the blank space indicated when reading the freehand writing is shown on the screen. The special characters are the opening and closing brackets. These are always in pairs. The First category which is shown here is they are called simple brackets or they are called parentheses. This type of brackets are called as braces. They are also called as flower brackets. This type of brackets is called as box type brackets, rectangular brackets by different people who use such kind of brackets. To perform addition, subtraction, multiplication, division between two quantities, whether a constant and another constant, constant and a variable, variable and a constant, or variable and variable, like that, these symbols are used. Plus indicates addition, minus is subtraction, star or asterisk is for multiplication, slash is used for division. Now, in the character set, this equal to and not symbol or exclamatory mark are the characters. The combination of this exclamatory mark and the equal to sign will be read as not equal to. That means this is equal to and the exclamatory mark stands for not, followed by equal to sign. So it is read as not equal to. Similarly, this symbol less than or greater than. It is also called a pair of brackets where these are called as carets. So this less than or equal to is not a single symbol. It is a combination of less than symbol and the equal to sign. Similarly, this is the combination of greater than symbol and equal to sign, which means greater than or equal to. So this one is called the hash sign. This is and or it is called ampersand. Full stop or period or decimal point is this dot here. This is comma, semicolon and colon and semicolon. This is single quotation, double quotation. This is also called as, single quotation is also called as apostrophe. Question mark symbol, this is backslash, a vertical bar. This is exclamatory mark which you have already included here when defining the not equal to sign. It is not specifically used in the programming language C, but it can be used in the data. Dollar sign is available here, percentage, and this is exponentiation or rising to a power. So by counting this, we get 2 plus 2 plus 2 6, plus 4 is 10. This is 11 and 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So these are 30 plus that 1 is the blank character also. Handwriting style varies as shown in the screen here. So uppercase letters there are 26, lowercase letters are 26, decimal digits are 10. Special characters are 1 plus 31, but the symbol at is not used as a character which is useful in programming, but it is used as a data. And this one is the blank or space which is produced by the pressing the space bar on the computer keyboard. So while making calculations, we use what are known as constants, the values of which remain unchanged during the solution of a problem. For example, there are several constants which generally we use. One of them is pi, another is the acceleration due to gravity, g. Third one is the base of natural logarithm, or e. This mu naught is called absolute permeability of free space or vacuum. Similarly, epsilon naught ಹಲೋ ಇಲ್ಲ ಕ್ಲಾಸ್ ನಡೀತಾ ಇದೆ, ಇದು ಜಾಯಿನ್ ಕೇಳಿ ಬೇಕಾದ್ರೆ. ಆಯ್ತು ಓಕೆ, ನೋ ಪ್ರಾಬ್ಲಮ್. ಇಲ್ಲ ನಾವು ಐ ಆಮ್ ಇನ್ ದಿ ಕ್ಲಾಸ್, ಯು ಕ್ಯಾನ್ ಟಾಕ್ ಲೇಟರ್. ಹಾಂ. Values which remain unchanged during the solution of a problem are called as constants. Examples we come across pi. Pi is the ratio of the circumference to the ಕದ ಮುಂದೆ ಕರ್ಕೊಂಡು ಹೋಗಿ. The examples of constants are pi, which is the ratio of the circumference of a circle to its diameter. G is acceleration due to gravity, which is used while using the Newton's laws of motion for connecting or finding a relationship between the mass and weight. E is the base of natural logarithm. Mu naught is called the absolute permeability of free space or vacuum, and epsilon naught is called the absolute permittivity of free space or vacuum. Constants are values which remain unchanged during the solution of a problem. Examples include but not limited to pi, g, e, mu naught, epsilon naught. Pi is the ratio of the circumference of a circle to its own diameter. G is the acceleration due to gravity, which varies from place to place and also varies from time to time. However, in solving a particular problem which was given in the examinations, etc., the value of G is treated as constant for solution of that particular problem. E is the base of natural logarithm. Mu naught is the absolute permeability of free space or vacuum. Epsilon naught is the absolute permittivity of free space. The value of pi given in the examinations or in problems in worked examples in textbooks are like 3.14, 3.142, 3.1415 or 3.1415926536, etc. So here some people have calculated the value of pi correct to 4,000 decimal places and more number of digits. But depending on the display that accommodates in the calculator, the number of digits will be kept as 10 digits in the 10-digit calculator or 5 digits in the 5 digits calculator, and so on. The value of G also given in problems will be like 9.81 meter per second square, 9.8 meter per second square, 10 meters per second square, depending on the problem that is given. The purpose is to see that calculation becomes simple when you take G as 10 meter per second square instead of 9.8 meter per second square or 9.81 meter per second square. In fact, in the FPS system or the so-called British system, the value of G is 32.2 feet per second square. Same thing in the centimeter gram second system or CGS system, the value of G is taken as 981 centimeters per second square. E is the base of natural logarithm. The value typically used is 2.718, 2.71828, 2.71828, 1828, but it won't repeat again as 1828. There will be other digits coming. Similarly, the value of absolute permeability of free space mu naught is given as 4 pi into 10 power minus 7 Henry per meter, and epsilon naught, the absolute permittivity of free space, is given as 8.854 into 10 power minus 12 farads per meter. In the textbooks on calculus, in the elementary chapter, they will mention that the letters in the beginning of the alphabet are represented as constants, and they will write ABC followed by ... like that. But here we are trying to keep the letters ABC, DEF, GHI, JKL, MN for use as constants when using C language, and usually in addition to these letters we use pi, the Greek letter which represents the ratio of the diameter and the circumference of the circle. That is, ratio of the circumference of a circle divided by its own diameter gives the constant pi. Since the Greek letter is not used in the character set of the C programming language, we try to use P followed by I, or some people will write P followed by the letter Y. Some people also write P followed by letter Y followed by letter E for the value of pi, so that it represents the ratio of the circumference of a circle to its diameter whenever its use is needed. Accordingly, the variables are the letters which are at the end of the alphabet. Typically, in the textbooks, they will write ... XYZ. So we will try to use something like A to N for constants and letters P to Z for variables, and we do not use the letter O for either constant or variable, because letter O and digit 0 we may get confused, so that is avoided. So suppose These rules are not actually engraved in hard, jet black, polished granite stones. These rules are only for our convenience. For example, we can say let R is equal to radius of the circle, D is equal to diameter of the circle, A is equal to area of the circle, P is equal to perimeter of the circle. Like that we can use. There are no hard and fast rules that letters starting from A, going along ABCD, ending with N need not be always used for representing constants, and the letters from P continued up to X, Y, Z may be used for variables. It is only a good practice so that the programmer will be able to easily identify by looking at which is the starting letter of the variable names if it has got more than one letters, so that he can easily identify a constant from a variable and vice versa. So, use of general rules is always advisable. However, deviations can be made depending on the convenience of the programmer. Once we have the constants and the variables, we have to connect them and do operations on them such as addition, subtraction, multiplication, division, powers, and roots. Here we only use algebra. The difference between arithmetic and algebra, as I could understand from people who knew about it from practical experience, is that in case of arithmetic, we cannot subtract a big number from a small number because of the simple reason that such an operation of subtracting a big number from a small number is treated as a meaningless operation in arithmetic, as explained to me by a person who was going for grazing the cattle in the villages, collecting the cattle from different households, taking them to the area where there is plenty of grass, allow them to eat the grass there, and in the evening bring back all the cattle and return the cattle to their respective houses to which they belong. That person, he told me that if you have only 1 rupee in your pocket, then you cannot give 2 rupees to anybody because you have only 1 rupee in your pocket. So that means it underlines the importance of the fact that big numbers cannot be subtracted from a small number, whereas in algebra we can subtract any number from any other number irrespective of their size. However, in algebra, when we say 4 minus 9, what actually do is we take the big number only, which is 9, subtract that 4, and result is 5, but we keep the sign of the big number, giving the answer as 4 minus 9 is equal to minus 5. So here onwards, in writing C programs, we use only algebra. That means we have to give importance to every variable, every constant, and the operations we are performing, such as addition, subtraction, multiplication, division, powers, and roots, etc., where importance must be given to the positive or negative sign of the quantities that are involved. So, the operations using algebra are performed between constants and or variables using what are called algebraic operators. These operators are the plus sign for performing addition between two quantities, minus sign for subtracting one from the other, and star or asterisk for multiplying one item by another item. Slash is for division of one item by another item. Whereas for finding the powers in C language, we have a library function or a built-in function or a mathematical function such as POW A comma B. What it does is, here the POW letter sequence indicates the name of the function, which takes in value of A and B, calculates inside the computer the value of A raised to the power of B, and bring back a result through the name POW, which may be used for any purpose as intended by the programmer or as needed in solving the given particular problem. Similarly, SQRT within bracket X is also a function which is available as a built-in function or a library function in the C language, which is used for determining the square root of the number x that is supplied to the function. Similarly, there is a function called TRUNC that is called trunk. It takes the value of P and it ignores the fractional part and returns the whole number part of the value of P. These are POW, SQRTX, TRUNC are the inbuilt or something like library functions which are made available in the same language so that users will be able to calculate on their own. Let us take a C program example. Before, normally, actually we go for learning various basic building blocks and then go for writing the program. After understanding what is a problem, what are the methods of solution that are available, which is the best method, which method we can take it for solution through using computer programs, etc. But to get a good idea in the beginning itself of how an example C program looks, let us examine a simple classroom example which is generally used for explaining to the students about the working and performance of computer oriented program learning purpose. See here, let us write a program whose purpose is to start output on a clear screen, which is the monitor screen which you are using on a laptop. On the laptop screen, there may be a lot of information, but when our computer program gives the results or displays the information for the use of the user of the program or the person who is writing the program, if he is trying to test the working of the program. To start displaying the results on a clear screen. That means it should not start from wherever the cursor is there. It might come to the first line of the leftmost position on the screen, so that we start on an empty screen or blank screen. Then we want the computer to give us the hint to the user, which is of user-friendly type. User-friendly type means that we generally use the words like please, so that it becomes more friendly. So we want the program to display the message, please enter value of radius equal to. At this time, if he is not glued his eyes onto the screen on the monitor, then a beep or audio alert may be given through the program, explaining him or drawing his attention, so that to tell him that computer is waiting for input from the user. So please act accordingly. Now imagine that the user enters 1.0 for the question, please enter value of radius equal to, where the user enters 1.0. Then area becomes like 3.142. It is because area of a circle, we know it is pi r square. Now r is 1, therefore r square is also 1, and pi r square means pi into 1. But pi, maybe when correct to 3 decimal places, we can use like 3.142. Therefore 3.142 into 1 into 1 will give 3.142 only, but the unit in this case depends on the unit that was used for the radius. If the radius is in centimeters, then area will be in centimeter square. If area is in meters, then area will be in meter square. If area is in kilometers, then radius also will be in kilometer. Radius in kilometers, area will be square kilometers. Now diameter is 2 times the radius, so 2 times of 1 is equal to 2.0. Perimeter is something like 2 pi r. Now 2 pi into r is 1, that means it is 2 pi, but pi is 3.142. So 2 times pi means it is 6.284. So perimeter becomes 6.284. The unit depends on the unit of measurement of radius. If radius is measured in millimeters, then perimeter is 6.284 millimeters. If radius is measured in kilometers, then perimeter is 6.284 kilometers. Like that, we'll have to use. Now, we want the computer to display a note to the user telling that please note down the results. Generally, while displaying the results or printing the results, the programmer always wishes to write the input data value also, so that if the user of the program is not happy with the results produced by the computer, then he will be able to use the input data to check what exactly was entered as input data to the computer for this problem. If there is a wrong entry, then naturally results will be wrong. In terms of computer terminology, such a thing is known as GIGO. That means GIGO. GI means garbage in, GO means garbage out. So GIGO means garbage in, garbage out. That is the basic principle of electronic data processing. So what it means is, if you give the correct data, then results will be correct, but if you give the wrong data, the results may not be useful. It will be useless. After the computer shows the message, please note down the results, and also gives a beep or an alert, an audio signal, so that the attention of the user is drawn for the waiting computer, which is expecting the user to act on the request made by the computer. So, please press enter key to continue. Is also computer will be waiting for the user to press the enter key. So on pressing the enter key, it will proceed to the next step and says, please enter next value for the radius what you wanted to find, the area, the diameter and the perimeter. Here a hint is given to the user that in case he has already calculated the area, the diameter, the perimeter when the radius is given for all the problems so far, then to leave the computer's execution stage, it is necessary to enter what is known as an end of data criteria. The end of data criteria is nothing but a value which is used not for calculating the needed results, such as the diameter, the area, the perimeter when the radius is given, but to signal the computer system to take into account that the user has already processed all the available data with him. He has no more data to process, and therefore computer may hand over control to the operating system and exit from continue to executing that program written by the user. It also alerts by using a beep sound or an alert sound, provided the computer is equipped with a sound card and the speaker is working. So after entering the next data, radius value 00 to quit, beep alert, it will message processing completed, thank you, please come again, please press enter key to quit. So it will be waiting, and when the user presses the enter key, it will hand over the control to the system, operating system, and terminates the execution of the user written program in C. In C program, all subproblems can be written in the form of what are called as functions. Functions are mainly classified into two main types. One is what is already written and made available in the compiler by the compiler designers, and those which are not there in the compiler but the user can define depending on his own requirement. So user defined functions and inbuilt functions. The inbuilt functions are called as sometimes as library functions also. So inbuilt functions or library functions are some of the standard mathematical and other functions, string handling functions, etc., input-output functions and things like that. They are already written and made available to the user. It is necessary for the user to make use of the appropriate function from among these available inbuilt or library functions. When whatever the ready-made functions that are available are not useful, but user has to write his own user-defined function, that is also possible, which can be included as a part of the program. Examples of inbuilt functions or library functions are what is called as main opening bracket closing bracket. This is followed by a pair of braces or flower brackets. Within these two, we can write whatever the information we want, which is called as a block. So, a C program, when executed, always the computer executes the function whose name is main opening bracket closing bracket, and it performs all the instructions given between these two pair of braces or flower brackets. Up to the end, it will stop on its own if the program is written in that fashion. Similarly, there is a program called printf. This is for display of the results on the monitor screen, and scanf for entry of data using the keyboard. This one is called as a while loop. It is a function where it will check for whether the condition is true or false. If the condition is true, which is written within the set of parentheses, then the control executes all the statements available between this opening and closing bracket, which is called as one block of instructions. Example of a user-defined function is something like given here. The example given is beep. This is a user-defined function for making alerts to the benefit of users when attention of the user is to be drawn to indicate the fact that the computer is waiting for input of data to be made by the user. So, user-defined function, one of them is beep. This is designed or written by the programmer. It uses the what are known as sound, delay, and no sound functions, which are available in the disk operating system. Normally known as DOS system, and therefore sound, delay, no sound, they are called as something like DOS commands. A typical program written in C language looks something like this. So here, as we told earlier, there is something like the printf, which is shown here. Please enter value of radius equal to this function like printf, and the reading like scanf, which comes in the next slide. They are defined in this function called stdio.h. So we are telling the computer to include the instructions which are described in stdio.h while compiling our program, because we are going to use some of the functions which are already defined and kept available for users for free by including this stdio.h called as a header file for standard input and output. Similarly, conio.h, is also a header file. It is standing for console input and output. Input means it is through the keyboard, output means it is on the monitor screen. Similarly, include math.h is another program area where all mathematical functions which are readily available for use by the user are kept in this header file called math.h. So they can be used. We don't have to write the detailed step-by-step procedure ourselves for using any of these standard mathematical functions. Similarly, the DOS.h is also a header file. It contains several dash commands about how to use them. For example, we already seen there are functions like sound, delay, no sound, etc. They are contained in this DOS function. So then the first statement is what is known as the main here, and main is the first function to be executed in the C programming C program, and we have to tell what type of data it gives us back and what type of data it takes in for processing. Here nothing is supplied or returned by this function main. That is indicated by writing void. Void main means this main program will not give back any useful results to the user. Similarly, the setup parenthesis without any data in between indicates it doesn't require any input data also for functioning. It starts with this brace which ends with a closing pair of brace, between which whatever is there, it is called as one complete block. The main program therefore performs using or evaluating every statement that is executable which is written within the pair of braces or the block of the main program. Now void beep is a user-defined function which is not there, and this writing indicates that the user is using this beep function like this, but as it is not a inbuilt function or a library function, user has defined a function by this name which will not give out anything outside, and also it doesn't require any input data but produces the beep sound. So this can be given either before the void main program, or it can be given inside the main program, or it can be given at the end of the main program. After the main program is ended, we can give that one. So here this type of a statement like float will tell us the nature of the data which is used in this problem. For example, R is the radius, D is the diameter, A is area, P is something like the perimeter, and pi is the ratio of the circumference of the circle to its diameter. So whether these things can be whole numbers or fractions. Generally, the values of radius measured will not be a whole number. It may contain fractional part, and that is when used for calculating the diameter, the area, the perimeter, etc. The answer obtained also will not be a whole number but will contain a fractional part. So the numbers which contain fractional parts are known as floating point numbers, and in C language we have to tell These belong to a category where fractional parts must be considered, that is indicated by writing this float, FLOAT float, followed by the list of variables where variables are separated by commas and included all here. The ending of every statement in a C program is a semicolon. Similarly, the value of pi, let us say we decided to use only 3-digit accuracy, such as pi is equal to 3.142. This will be used for solving all problems in this program, and therefore the value is defined here itself in the beginning of the program. Now the CLR SCR is a function which is inbuilt in this conio.h header file. So that job is to take the cursor to the leftmost position of the first line from the top of the screen, erasing any information that may be present in the monitor screen. Then we want the computer to print out this message or display this message on the monitor screen. That is, please enter value of radius. Now here the /n is to indicate go to the beginning of the next line. That means we don't want to print the message exactly at the top edge of the monitor screen, but we wish to give one line gap and start from the second line. So /n is called the new line character or the next line character. It takes the cursor to the beginning of the next line. Then beep is the user defined program, and that produces the audio sound. It is an alert to alert the user about and giving him the idea that computer is waiting for his input so that it may be given to continue with the problem solution. So that means in the beginning, once we have this include statements to include those things which are available in the library or something like built-in functions, we will come for this void main. It has an opening brace and ending closing brace. The information lies between this in left flower bracket or brace and the right brace or flower bracket is called as a block. So depending on the information content here, the computer always starts executing everything coming under the main function, and therefore it executes the block as per the instructions written by the programmer. So the block information contained within the block of the main function are void beep. This is what is called as a function declaration. That means we are trying to tell the compiler that we have written a user-defined function which is identified as beep. So it is described at either at the beginning of this main function or at the end of the main function by the user himself. So after allotting the type of data such as floating point for radius, diameter, area, perimeter, and the value of pi, the ratio of the circumference to its diameter, that is 3.142. is having the portions of the number which having the fractional part also. And here this pi is one of those which is defined here to be of the type floating point, will keep the value of 3.142. So in this program, we can use this pi to represent 3.142 wherever such calculations or algebra is involved using the value of pi. Now, the CLR SCR is a function that erases information contained on the monitor screen and takes the cursor to the first line and leftmost position on the monitor screen. The printf, this \n will take the cursor to the first position of the next line. So it is called as a new line character. Then it displays the message, please enter value of radius equal to. The beep function, which is user defined, will try to produce an audio alarm or something like a beep sound. It is also called alerting the user that computer is waiting for some input from the user. Now scanf will be the input function. It receives the value entered by the user for the question posed above and keep it in the place in the memory location in the computer memory, which is where this R is stored and its address is known to the compiler. And the %f says that R will be of that type which uses the floating point type defined here. That means it can have fractional parts also. So once the data is received, then we check here whether the data that is read, just read, is it greater than 00. That means, see, if you want to calculate the area, the diameter, the perimeter of a circle, when the radius is given, we don't want to use the number as 0 or negative for the radius value, because 0 as radius, drawing circle with a negative size like -5 as radius are meaningless. So therefore, we want to avoid such things if inadvertently entered by the user. So we are making sure that the radius value entered is only a positive value. So this while function checks whether the user entered value for radius, is it greater than 0 or less than or equal to 0. Only if it is greater than, it will execute all the statements which comes within the block which is identified by a opening brace and a closing brace of the while function. So once it is positive, it comes here, 0 or negative, it skips all this and goes to end where the block ends with the closing brace like this, which is a matching one at the end. Then it calculates area using pi r square. Here, instead of r square, we have used something like r into r. In fact, computer is fastest in performing addition operation. It takes slightly more time for performing the negative operation or subtraction. It takes little more time than subtraction to perform multiplication. Similarly, it takes more time for division when it is done between a constant and a variable, or a constant and a constant, or a variable and a constant, or a variable and a variable. So therefore, to reduce few microseconds, instead of writing r square, we are using r multiplied by r. Similarly, diameter of the circle can be obtained by multiplying 2 by r or r by 2, giving 2r. But as we explained, addition of operation is always faster than multiplication. Therefore, instead of writing 2 into r, which is a multiplication that takes longer time, we use r plus r because addition is the fastest operation in the computer, and that saves us few microseconds time for performing the calculations. Similarly, perimeter is given by 2 pi r, but 2 into pi value, if we multiply, we spend some microseconds, whereas if we multiply 2 and pi ourselves and write the value, it saves few microseconds. Therefore, we write it as 6.284 into R2, R for the perimeter. Once these calculations are made, it is time to display the results of processing. It is a good practice to always include the input data also while displaying the results, because of the simple reason that in case of the output results are not acceptable for us, then we can check whether it is true or false by checking what was the input data we entered for obtaining these results. So, for that purpose, when we display the results, it is always better to include the input data also to be displayed on the screen, so that the user who is not happy with the results can cross-check whether he entered the actual input data correctly. So once this is done, computer will print out giving 2 lines here, radius equal to, and write the value of r. Then next line, again it gives another line gap, writes area equal to, write the value of a, which is represent the area. Then print the diameter, and then after giving a gap of another line, and it will print the diameter using that floating point format. This one is again giving one line gap further, then write perimeter equal to, and write the value of P, the perimeter calculated using that floating point representation method. Then it is giving the message after giving 2 lines gap, please note down the results. This is instruction given by the, as if it is given by the computer to the user. Once that write note message is given by the computer, this beep function will give an alert to give alarm or a beep sound, so that to draw the attention of the user that it is waiting for his input to proceed further. Then it prints, please press enter key to continue, and this get character will be waiting for opportunity to see whether this is answered by the user. That is, if user presses enter key, it will continue further. Then it will say print enter next radius value 002 exit. That means here the user is interested in solving another problem or not using the same execution time is to be indicated by the user to the computer. So here the programmer has given a hint that enter 0.0 to exit. That means we are using r is equal to 0.0 as what is known as end of data criteria. That means 0.0 is used here not for determining the area, the perimeter, the diameter, etc., but it is used only for displaying the message telling the computer that the user has already used all available data for processing. He don't want any more, or he don't have any more information to process. Therefore, the control of the program may be handed over to the operating system, and it is necessary to exit the user-defined, user-written C program. So when the beep is heard, the user is supposed to press the enter key. Then it will print the next message here. Please enter next radius value. A hint is given here so that if we don't have any more data to process, we can enter it as 0.0. In which case, if the answer is yes and greater than 0, then it continues for calculating, reading the radius, going for calculating the area, diameter, perimeter, keeps on continuing like that. So the program comes to stop on its own when the radius value for the next radius value, that is for the next problem, is entered as 0.0, and it exits from the program and hands over the control to the operating system. So if the user enters 0.0, then the computer is here displays the message, processing is completed, thank you, please come again, please press enter key to quit. Then it alerts using the beep sound. Now get CHE will be waiting for the user to enter the data. Now this bracket which is here is the end of the main block, main functions block, and this one is the user-defined function. So this user-defined function like sound 200, delay 500, no sound, they are there in dos.h, the header file. So that we have seen in the beginning itself. Now using these DOS commands, this beep command is prepared by the user. So what he will say? Void beep. That means this program void, it will not give out anything. It is self-contained. And within the parentheses, there is nothing here, the set of parentheses. So what it says is, this doesn't require any input except its name, BEP. Now, when that is written in the main program, the control comes here, it performs whatever is given between this opening bracket and the closing curve bracket. That is, it executes the command sound 200. This gives something like the tone that is used to produce the sound. Delay 500 is in milliseconds. That means it is half a second. It will wait. Then no sound. No sound means it will stop the generation of the sound by the speaker. Then every function must have a return statement so that control will go back to the place where it was called so that it can continue execution of the next statement available in the program. So the user-defined beep function looks like this: void beep, opening bracket, closing bracket. Here, this semicolon is not to be written. It is written only in the something like declaration statement in the beginning of the main program, what we had written. Here it is not there. And this one indicates the block of instructions which are included between this opening brace and the closing bracket. Now, here are the three commands which will produce the beep sound for us. And return takes the control from this beep function at the place where it was called, so that it goes for the next statement available for execution. Now we will stop here and we will continue our next session on the next Saturday at 6 p.m. sharp. So please, the viewers, whoever sees the recording of this virtual session that is conducted on all Saturdays between 6 p.m. and 8 p.m., which is planned to cover almost all subjects of mechanical and aeronautical So let us stop here. Please spread the message through all your contacts to as many people as possible, so that somebody in some corner of the world will be able to get some benefit out of these programs, either by attending the virtual program or by viewing or downloading and viewing the recorded session, so that he will be able to get some benefit out of all this series of programs. Thank you and goodbye for today.